Welcome to our journey into the fascinating world of quantum computing. Today, we're diving into the essential components that make quantum computation possible, quantum gates. In classical computing, logic gates manipulate bits, values of 0 or 1, to perform computations. Quantum computing takes a step further with qubits, which can exist in a superposition of states. Quantum gates are special operations that manipulate the states of these qubits while preserving the principles of quantum mechanics. Specifically, they ensure that the total probability of finding a qubit in the state 0 or 1 remains 1. One important family of quantum gates is the Pauli gate family. They perform 180-degree rotations around the x, y, and z axis of the Bloch sphere, where quantum states are represented as points on the surface of the sphere. Let's focus on the X-gate today. Just as classical bits can be flipped from 0 to 1, a qubit can also be flipped from the state 0 to the state 1. The X-gate performs this flipping operation. So, given a general 1-qubit state, the X-gate swaps the amplitudes of the state 0 and 1. Quantum gates can also be applied sequentially to create quantum circuits. If we apply the X-gate twice, we effectively flip the qubit twice, returning it to its original state. Now, let's explore how the X-gate modifies the state in the Bloch sphere. In this representation, the state 0 is at the North Pole, and the state 1 is at the South Pole. The X-gate corresponds to a 180-degree rotation around the x-axis. So, applying the X-gate to a qubit in a state 0 rotates its state vector from the North Pole to the South Pole. Then, applying the X-gate a second time rotates it back to the North Pole, returning to its original state. Understanding the X-gate is fundamental to grasping how quantum computations are performed. It serves as the quantum equivalent of the classical NOT gate, flipping the qubit states and enabling quantum algorithms. By visualizing its effect on the Bloch sphere, we gain deeper insights into quantum state manipulation, paving the way for exploring more advanced quantum operations in future lessons.